All right, let's start with number 1 on the test review. In the circle X, arc AC is 150 degrees. So that tells me from here all the way around to C, because there's only 2 letters, I can guarantee it's a short way, that's 150 degrees. And they want to know the measure of arc BD. So they want to know from here all the way back around to here. Okay, so let's look at this. From B all the way around to D, they overlap. But more importantly, AC, the chord, is actually congruent to BD, the chord. And if the chords are congruent, it means so are their arcs. So arc BD is 150 degrees. All right, in circle O, moving on to number 2, angle 1 and angle 2 are equal to one another. These are equal. And angle 3 is 100 degrees. So we want to know the measure of arc RS. Okay, so in order to know the measure of arc RS, the first one, we need to know the measure of angle 1. Since it's a central angle, the arc will be the same. So we know that 1 plus 2 plus 3, angle 1, plus angle 2, plus angle 3, all equal lines. That equals 180 degrees. And angle 1 and angle 2 are the same. X plus angle 3, which is 100, equal 180. That makes 2x equal to 80, which makes x equal to 40. All right, so if angle 1 is 40, that means arc RS is 40 degrees as well. Now we want the measure of arc SRU. So that's got 3 letters, which is going to remind us that it's a long arc. It's a major arc. So from S to R all the way around to U. Now, we just determined that this part was 40 degrees, and the rest of the circle is 180. So 40 plus 180 is 220 degrees. All right, number 3. We have circle C, and SV and RU are diameters. They've confirmed that, which means they're just straight lines, SV and RU. And we know that angle SCT, as marked, is 70 degrees. And we know that measure of angle UCV is 45. So we want, first of all, arc RS. All right, so we want this arc RS right here. And this arc is going to be equal, since this is just 2 lines right here, and these angles are congruent because they are vertical angles. It means this angle right here will be 45 degrees as well, and this arc is 45 degrees. The next one, we want arc TV. Okay, so that would be T around to V. You can see that it's not quite half a circle. It's actually the semicircle, but minus the 70 degree arc. So since the semicircle would be 180 minus 70 degrees, that would actually give us 110 degrees for arc TV. All right, next measure of arc VS. So from V all the way around to S. Well, since VS was a diameter, from V all the way around to S is half of the circle, or 180 degrees. All right, number 4. Given circle M and AC is a diameter, as we see right here, straight through the center, and angle A is 35 degrees, which means this part right here is 35 degrees, we want to first find out angle B. So if I think about A, B, and M making up a triangle, this triangle is isosceles because MA and MB are both radii. And if it's an isosceles triangle, that means the base angles are congruent, which means angle B is also 35 degrees. Next, we want angle CMB. So let's look at this. If this is a 35 degree angle, angle A right here, that means that it is half of this arc, making the arc 70 degrees. And angle CMB, which is right here, CMB, is a central angle cutting off the same 70 degree arc, which means it is 70 degrees itself. All right, moving on to numbers 5 and 6. I added a little detail here that OK has to actually be tangent to the circle at point N, so I can guarantee that's a point of tangency. So in this circle L, KJ is 6, like we marked right over here. NO is 4. OP is 2. and this would actually be point P right there. And we want to find the measure of KL in simplified radical form. KL. So this is what we want to fill in. It's a little bit complicated. Okay, so first what we're going to do is I know that if this is 6, then this is also 6 because they both come from point K and they are tangent to the circle, so that means they are congruent. And since this is tangent to the circle, we can do a couple of different things here. I'm going to try and find the radius of the circle right away. And I'm not sure if this is not by any means the only way to do this. Okay, so I'm going to actually drop the radius down to n, and I know that makes a right angle. And I know that we don't know the radius here, and that's going to be the same right there. So I'm going to do the Pythagorean theorem that x squared plus 4 squared will equal x plus 2 squared. All right, x squared plus 4 squared is 16. Equals, now this I have to FOIL out, so this is really x plus 2 times x plus 2, which becomes x squared plus 2x plus another 2x, that's 4x plus 4. All right, the x squareds nicely cancel, and if I subtract the 4 from the other side, I get 12 equals 4x, so x happens to equal 3, which is quite nice. So now I know that right here, this x is now 3, and that's now 3. So now KL makes another right triangle, and that's our new thing that we're looking for. I'm going to call it y. And so now I can say that 3 squared plus 6 squared equals y squared, and that would be 9 plus 36. 9 plus 36 is 45. Equal to y squared, and so y is the square root of 45, which is the same thing since 45 is 9 times 5. That's the same thing as 3 root 5 equals y. All right, number 6. Find the following measures for circle A. So here I have circle A. I'm just going to move this out of the way. Let's try a different color here. Let me close this. Okay. All right. So we have circle A, this kind of crazy looking circle over here. We want to know first of all the measure of angle ECD. So we start at E, going to C, and then back to D. E, C, D. This is an angle whose vertex is on the circle, and hopefully you'll remember on the circle is half of the arc. Since this arc is 40 degrees, that makes this angle 20 degrees. All right, next one, we have arc CE. So this arc right here. Okay, well, I can see that CAD is a diameter, which means that it cuts the circle in half. So that means this whole arc will be 180 degrees. And since we're missing the 40 degrees, that leaves us with 140 degrees for arc CE. All right, next one, BFD. Let me change my colors here. We go from B to F to D. This is just like that first one we did where the vertex is on the circle, and so it's equal to half of the arc. And since this arc is 30 degrees, the angle will be 15 degrees. And last but not least, we're looking for CBD. CBD. That angle. Okay. It doesn't look like it's actually drawn in there, but we can draw that in. So C, let me kind of do this in a new color. C, B, and then D. Well, once again, since CD is a diameter, it's inscribed inside the circle, and so therefore it is going to be half of this 180 degrees that we came up with for the semicircle, and so therefore it will be 90 degrees. In fact, all angles inscribed in a semicircle are equal to 90 degrees.